So good evening all. Here I'm going to start a very good session, or maybe one of the most important session I can say, and that is on machine learning. So I welcome you all for this particular workshop. We have two sessions. The first session is we are conducting today, that is on 9th October, and the second session is on 11th of October. In this first session, I'll be taking the basic of machine learning, and also we'll try to cover linear regression model. Here I'm going to take the simple linear regression model so that everyone understand the concept of linear regression model. I won't be discussing all the algorithm in this particular session, as it is going to take a lot of time if I to explain all the algorithm. Rather, I'll be focusing only on specific model here. So before we start the session, let me tell you what is our today agenda. I'll be covering what the machine learning is. So it includes the introduction part, why machine learning, what is the need of machine learning. So just to give the brief idea about the machine learning. Next, I'll be covering about the types of machine learning life cycle, and then we are going to apply this machine learning with the help of example here. So this is what the today's agenda. Obviously, we'll be covering something more in the next session only, that is related to logistic regression. The focus is very much clear that we need to understand the machine learning and the application and how to apply. I hope you are clear with the agenda. Now I'm starting with the first thing first here. So there is a prerequisite for this particular workshop, and the expectations are that most of you guys already know some mathematics. You can say the fundamental knowledge about the probability and the linear algebra, should have some basic knowledge about the Python, should know some, the you can say the basic concept of derivatives of single variable, multivariate functions. So there are some prerequisite, although I'll be covering more about the machine learning and the Python, that is a major requirement here. Let's see now what is machine learning. Now, most of you guys must be hearing about artificial intelligence and machine learning, as this is one of the area which is most in demand. Why we are discussing about machine learning? The reason is most of us are very much interested to do the prediction. Now, how do you do prediction here? What is the base of prediction? If you want to predict something like maybe your business, you would like to predict like how is the future of your business? How is the future of your career? How is the future of your, you can say, your sales, whether you are going to have the sales or not, or whether the tomorrow the weather is, how is the weather prediction. So we always like to have some prediction. But then how do you predict? What is the base of prediction here? The base of prediction is the input data. The way you give the input data, based on that, with the help of mathematical, or you can say statistical model, we do have certain prediction now. So what we have to understand in this case, as a human being, we do also have some prediction, like whenever we see the weather is sunny, we feel like it's a summer, right? And whenever we feel like it's raining, so it's like, how do you predict? It's based on the temperature. You say like whether how the weather is, right? So based on even like, the kind of marketing you do, the way you do marketing, or the investment in the marketing, you can predict the sales. So like that, there are many more predictions. So there is an input data, and based on the input data, there is a output, or there is a prediction. Or you can calculate some values here. For example, you would like to calculate the value of any product. How do you calculate the value? Let's say take the example of pizza here. How do you calculate the value of the pizza? Maybe certain parameters could be the size of the pizza determine the pizza value. So, or even you can say calculation of the let's say house value you would like to predict. How do you predict the house value? So based on certain input data. So in all cases, what we are doing is we are giving some input data here, and based on the input data, there is a statistical model which gives you certain prediction that what will be the values of the product, right? So here we are trying to understand what is machine learning. So machine learning is all about like how do you give the input data, and based on that input data, based on the algorithm, is, there is a prediction now. So it uses a various algorithm for that. It could be a linear regression, it could be a logistic regression, or many more. So we will be understanding some of the algorithm in this machine learning itself. So objective is to give the input data, and based on that, we will be providing a mathematical model or statistical model, and we understand which are the built-in models available in the Python in this case. So it is all based on the historical data or the information now. How this machine learning term came and when it came. So it was first introduced by the Arthur Samel in 1959 itself. And what he says that machine learning enables the machines automatically to automatically learn from the data and improve the performance from the experience. So this is the way the various definitions are available, which again, finally the objective is to predict things without being explicitly programmed. That is what the definition says. So how does this machine learning works? I have given you some, the idea like, it is all based on the input data or the historical data or the past data. With that data, we call training data. So here, like how we are giving the training to the child, the way you provide the input data to the child, the same way we are providing the input data to the machine. What kind of input data we give it to the child? We are giving certain instruction that this is what you have to do it. This is what you should do. This is what you should not do. Like that, we need to tell the machine what to do, what to not do. So there is a training data for that. And that data, depends on data, the machine, with the help of the logical model, with the help of the model, it start giving the output here. So we will understand this machine learning in more detail. Let us understand some feature here. Feature of the machine learning includes it's like to detect the various patterns of the given data, what exactly happens in the features. It understands the various pattern now, because when you talk about input data, you have a varieties of data in this case. And you will be learning the complete machine learning life cycle. There I will be explaining you like how exactly it works then. So it has a various patterns of data, and it understands then. It learn from the past experience or the past data and improve the performance automatically. So even there is a one more, similar term is available, like we call data mining also. So this is machine learning is all data driven. The way you give the data, or you can say the more the data you give it, better the prediction will be. We'll understand but there are many more things to do. It's not just like to provide the data. We need to understand like how to give the data, and then how to clean the data. There are many more things to do, and that we'll be learning in the next session. Fine. So now let us see like what is the need of machine learning now. See, there are many things to do. Now, as a human, you have certain limitations. You cannot do each and every task. For example, human cannot access the huge amount of data manually. If let's say, for example, there's a big data, to access that data is really challenging for the human. So in that case, what we do, we provide the input to the computer here, and based on the computer, there's a machine learning, so here the machine learning comes into the picture. I can see there is some question here. Okay, so I think just put the comment when there is a questions here. Okay, so understand the need here that everybody will be using the machine learning for certain problem, right? So understand whatever problem you can solve using the machine learning then. So what we do in the machine learning, we train the algorithms, provide the huge amount of data, then we explore the data here, and you are going to see how you are going to explore the data, and then based on that we construct the model, and based on that there is a prediction, right? So all this thing we are going to because of all this process, you are going to save your time as well as money. Now machine learning helps to save the time and money, because whatever the job the human find this bit difficult and complex can be done easily by the machine now. So there is a need. There are many reasons why machine learning is there. The one of the reason is there is a rapid increment in the production of data. The kind of data which every day we are producing. Look at the kind of data. You are getting the data from the Facebook, or you are getting from the data from Twitter. You are getting the data from the various sources. Everybody is producing the huge amount of data. Now, if you want to predict when we have so much of data, and if you want to predict something, it's very complex for the human. So what is the solution for that? We need to train the machine with the filter data, and then ask the machine to predict in that case. Machine learning helps to solve the complex problem which are very difficult for the human. Machine learning help you to make the decision in a various sector, including the finance also. So you must have seen in the case of equity, or if you would like to decide whether to buy some stock or not, here you can take the help of machine learning. There are lots of case study where which are connected to equity. So if you like to really make the money, you can use a machine learning algorithm and decide where to invest and where not to invest, which is the best stock for you. I'll tell you, if you really want to make the money, understand the stock. Understand the various stock. Then means you have to do the analysis of various stock. So how do you do analysis of various stocks for that? So you may have, like, let's say for example, Infosys stock. You have like a blue chip company stock now. Now this blue chip company stock, you like to do analysis how they are performing. For that you have to give the data of almost 10 years. And like all these companies, they are there from past 15 to 20 years now, and this data is also available. Take the data as an input. Let me tell you, like, this is like a case study for you guys also. Let us do this practically, and I'll tell you how to do this practically with the example. So what you do, once you actually, let's say, once I finish this particular workshop, you think about the data. First of all, like, where you can get the data. You are going to get the data from stock site itself. There are various stock sites where you will get the data, and from there, what you do the stock analysis and find out which particular stock or the company is performing well, how they are performing. Even you have to see, like, it's not like the 1 year, 2 year data. Look for at least 10-year data, because as I say, your accuracy or the prediction, it is based on the historical data. It is based on how much data you are giving. More data you will give it to the machine, the better the prediction will be. So if you like to now invest money, will you invest money with an analysis, or will you invest just because somebody asked you to invest? Obviously not, because even if somebody is a consultant, that's fine. He must have done the analysis, then it is fine. But if somebody has not done the analysis and you like to invest, then first do the analysis, and then with the help of this analysis, give that data to the machine learning algorithm, and ask the machine learning algorithm where I should invest money. And definitely, if this question you ask machine learn with the help of machine learning algorithm, you'll get certain prediction also, that okay, now you should go for whether SBI blue chip, SBI blue chip equity, or HDFC, or Infosys, or some other stock. So you will get some idea. This is all because the machine learning gives you the power of decision making also. So really, if you want to take because see, you will not have that capacity to understand the entire data of all the stocks and all the company that you can understand. Can you store that 10 years of Infosys data, or maybe any company you take it, maybe the IBM data or Google data? You cannot. But machine, yes, you can give that data to the machine and ask machine based on that 10 years or 15 years data to predict and give the suggestions to you. So you can take the suggestion from this machine and you can have the decision. So this all will help you for the stock market also. So let me tell you, like, machine learning is very, very important field for each and every one of you. Whichever the business you are, whichever the field you are, everywhere there is a machine learning. Everywhere you can use a machine learning, I can say, rather than there is a machine learning. How you can use machine learning, I will tell you with a various applications in the machine learning also. Google is already using machine learning from the beginning on all the case of whichever the application you look, whether it is a application into Facebook, or maybe you can say Google Map, or even the email spam. Everywhere there is a machine learning. So you must have seen there are various examples which are there for the machine learning itself. So Google Photos, where with the help of Google Photo, it recognizes the faces, location, and the emotion. So this is just example like how machine learning. So there is a face recognition. So if you like to know like how face recognition is used, so Google is one of the example. The Google Photo, then Gmail, which analyze the content of the email and provide the smart replies also. So this way Gmail is using the machine learning. And like in email also there is a spam filtering, the important email, and all that is done automatically for you. Google now is another great example of machine learning. Also it includes the AI. It is not just the machine learning, it also includes the AI here. YouTube is also using the machine learning, right, for giving the ranking to your videos. Like it's telling, like your videos ranking is done by some parameters. It will look at the input data, like what is the watch time of that video, what is the video length, how many subscribers are there, how the users are interacting. So there are various factors by which YouTube do the ranking to your videos. So again, it is YouTube is using the machine learning. If you like, try to search, like for example, we have put our video in the YouTube, and I wanted to search in the YouTube. How does it work? So I just put Python tutorial for the beginner in the YouTube channel, and I could see that how it ranks in our YouTube channel also. So this helps us to use the machine learning now. There is a question that what is the difference between the machine learning and AI? Although I have explained this in my previous workshop, but let me give here. The machine learning is a subset of artificial intelligence. I'll give here the input, like artificial intelligence is like, you can say, where how machine behaves like a human, like it's like mimicking to the human itself. Whereas machine learning is not like mimicking to human behavior. Right, so this is a big difference. So AI is you can say a term where it is like how human behave, you want the machines also should behave. That is what the expectation in the AI. Whereas in the machine learning, you have some problem solving, you have some prediction to do. So we say that's a machine learning is a subset of artificial intelligence. But for detail, I will recommend for you, like please watch my previous video where I have covered the detailed difference between artificial intelligence, machine learning, and the deep learning, because it's a very huge topic. Again, I have covered in the previous workshop. And yeah, so you will see like they are connected to each other: AI, machine learning, and deep learning. So here first comes AI, then machine learning, and then deep learning. So deep learning is a subset of then machine learning. So now when to use machine learning, maybe we can say simple problems. If you would like to do it, you can go for machine learning, like solving the like a business analytics problem or weather forecasting, or so wherever there's a simple problems which are very easy to do, which you can give as input data to the machine and can be predicted. So there machine learning comes. But when there is something where the data is very huge and you require like maybe you can say there are some problems which are very complex problem, then the deep learning comes to the picture, like image recognition, where like there are deep learning means there are various algorithm again, like neural network programming is there. So there deep learning comes into picture. Now it all depends on the types of problem you need to use, whether you need to use either machine learning or the deep learning. And when you talk about deep learning, it is really related to AI then, right? So I'd like to see if any other question is there now. Yes, I think yeah. So I will request you to look at my previous video where I have covered the differences between machine learning, AI, and the deep learning. Because this particular workshop, my focus is to give just the idea about machine learning, not about the AI and not about the deep learning also. But to tell you like again, briefly, like let me tell you like there are various applications where machine learning is used. Take any example, like maybe you can say image recognition, speech recognition, traffic prediction, product recommendation, self-driving car, email, whether it's a spam or malware filtering, virtual personal assistant. In my previous workshop, I have shown the demo also for each and every application which are written here. Then is the online fraud detection, then stock market trading, medical diagnosis, and automatic language translation. So like that, there are several applications which can be this application could be the project for you. Let me look, you can work in the various segment. Machine learning is for all the segment or all the domain, you can say, whichever the domain you are, whether you are from the business domain or you are in some maybe automobile domains or finance domain or marketing, any domain you take it, every domain you can use machine learning, you can use artificial intelligence, you can use deep learning, but it all depends on the types of problem you like to solve. Decide first which type of problem you like to solve, and based on that you can go for the machine learning then. Yeah, so I told you, like, there are, yes, various applications are there. Again, as you are already aware about the various application, because you are using it in the day-to-day life. You are talking to the Siri, how you're talking to Siri, how you're talking to the, the Google Assistant. So all this because of machine learning and the AI-based application. Even the Netflix, they are recommending some, some videos that which is based on your user experience. So whatever your experience is there, whichever the types of video you watch generally, based on that, Netflix will tell you that, that these are the video which are for you, right? All these are algorithms. There is some logic, and this is all like the data, how actually these programs are gathering the data from you, that you will not be knowing also. So without telling you, like, you'll be knowing, Netflix is taking the input data. It's all automatically done, and then recommending you to watch the specific video here. Even Amazon, whenever you're buying some product, they're recommended by the Amazon. Why? Based on whatever the previous search you're done in the Amazon, whatever the search into Google, all that search is all taken as an input. And based on that, Amazon is doing the marketing, Google is doing the marketing, but it again includes the various things. It includes the machine learning as well as AI together. I would like to see some more questions are there. So in between, I'm just checking the question also. Can machine learning and AI help in a space-related application? Okay, so definitely it helps. Obviously, that's why the Elon Musk is using that. Elon Musk, see, whichever the type of application, because why I'm saying human cannot do each and everything, right? So you need to have use some machine to capture the data. For example, in the case of satellite image processing, satellite images are captured, and that image processing is done based on that. Even the traffic management, right? You are able to use a Google map, and like how the traffic congestion is. You are already clear about that. Why? Because there is some image processing is going on, right? So someone is there to help you out. Google is taking that data from the various satellite, from the various cameras and all that data. With the help of that data, you come to know how is a traffic situation, right? So yes, there are several examples to tell you about the machine learning and AI, but let me tell you, machine learning is to solve the you can say simple, or maybe more I can say it's like a subset of AI now in this case. So I told, like for example, prediction of data, or you have some algorithm to solve the problem. So simple problem, if you want to solve it, then machine learning will. But then when there are problems are so complex, that becomes very difficult, where you require to give a lot of input data, where the lot of hidden layers are there, right? You need a more accuracy. If you need a more accuracy, see, if you need a, let's say, accuracy of 90% and all, then you go for the AI. More the accuracy you need it, more the data you require to give it. So AI or deep learning comes into where you are giving so much of data, where there's a big data you are giving as input data. But when you talk about the machine learning, you may not have that much of data in that case. So there is a difference between machine learning and AI in that case. So there are various applications which are where the machine learning is used. I already talked about like face recognition, even the self-driving car. There also machine learning is used. So in all cases, machine learning is there. So let me see, like, okay, fine. So I think my team has already shared you the previous YouTube link, where I have already explained each and every application in detail, that how machine learning and AI can be used for solving the problem. So that was all done in my previous workshop only. Now let me tell you giving you some idea, like there are various algorithms in the machine learning. And there are some special categories of the machine learning, like supervised machine learning, unsupervised machine learning, and reinforcement learning. Now, why these types of machine learning? What is this supervised machine learning? So we have a different types of machine learning. Supervised, what the name supervised means, what the name unsupervised means, or what exactly reinforcement learning. And if there is a supervised machine learning, what type of problem you can solve with the help of supervised machine learning, and what type of problem you can solve with the help of unsupervised machine learning. Again, there is a confusion like which algorithm I should use for the supervised machine learning and which algorithm we should be using for the like you can say unsupervised or reinforcement learning. So there are different types of business problem here. For example, if you have to classification related problems or regression related problem, you can go for supervised machine learning. Now again, in the classification, we have a fraud detection, we have a customer retention, we have diagnostic related problem, or we have forecasting related problem or prediction related problem. So based on the type of problem, you have a various types of machine learning algorithm. Again, there are so many categories available in each case, like even the regression. So if I to just talk about regression analysis, there are many more things to do in the regression itself, like linear regression, logistic regression, and many more things are there in that case. Multilinear regression. So these are like various algorithms. But why? Because it all depends on the kind of problem and kind of input data you would like to have. So as the input data change and the type of problem change, you have a various types of algorithm as well as the solutions are there. So we'll be taking some area like, and again, I'm giving you here some idea like you can see in this diagram also. If you like to solve the problem like you like to decide like where I should like do the digital marketing. So which is my target market? So customer segmentation, if you like to do it. And it's a huge data. Let's say you have huge population and you don't have label data. So when there's no label data, you go for unsupervised machine learning. When there's a label data, go for supervised machine learning. When there is a training data, which is again, having the the complete learning there, like a reinforcement learning comes. So I will be telling you in more detail about all these things. But here I like to give the example before we go ahead. So let me give the example and then I will tell you, explain you each and every time what is supervised machine learning means, what is unsupervised machine learning means, what is semi-supervised machine learning means, what is reinforcement learning means. So all these things I'll be explaining in detail. But here let me tell you with an example first. Whenever you like to predict something, house prediction, so you like to predict the house price prediction, you have some regression, you have some input data here, which is a label data. Now supervised learning means you have a data where supervised data means is a trained data is there, where we have training data, which is a label data. And when the data is label data, which is a known data to us, based on that, if you are predicting, that is what supervised learning is. It's not something which is unknown here. We don't know. It's not something you're taking any data here. It's not a random data, or it's not just the population data where we don't have label here. So here the data is known to us, means there's a label data is there. And so in this case, you will see there are two things like continuous target variable and categorical target. So there are different types of variable we have here. One is called continuous target variable. So what is continuous target variable means? Where you have a variable value which is changing based on the the independent variable. There is a dependent variable. So again, I'll be explaining this term, what is dependent, what is independent variable. So we have one variable called independent variable, right? Which is the maybe you can say we have some sales data. In the sales data, what kind of will be there, data will be there, data will be the, so, and there is a something like, let's say, year data, how many years, how the sales are happening based on the years. So we have, let's say, something data which is a continuous data, which is a year wise, how the sales is happening in the yearly. And the year data is like known to us, like it's something which is a independent data. Year data is independent data, but the sales is something which is a dependent. The every year you're like, let's say you say like 2000, you're calculating the sales from the year 2010 2020. So how the sales is happening from the timeline from 2010 to 2020. So every year you will see some variation in the sales. It may go up, it may go down, right? So that is what that variable we call, where the that is all, like you can say, the dependent. maybe based on some it may not be just because of the time, it could be because of some other reason. So I'm just giving you one example, a simple one. Based on the time could be there, or based on marketing, you have some data like that there's an investment in the marketing, and based on the marketing there's a sales happening. So something which is known to us and something which you need to predict now. So based on whatever the input data you give it, that is all we called so input data is there in the case of supervised machine learning, and there are variables here we call continuous target variable, and there's another where there's a prediction now. Categorical means something where the value is not changing there, right? There is like your decision making is there. For example, you want to say true or false, yes or no, right? Or you would like to identify whether there is a cat or dog. So that comes into the categorical data. So here you just have a decision making kind of thing here. So in the medical image, you would like to diagnose the image. Based on the image, you like to find out the kind of disease. So that all thing can be done by the classification related algorithm. So that is comes in the supervised machine learning. Then there is an unsupervised machine learning. Again, there are different types of problem here. The data is not the label data here, right? So we have problems like clustering related problem or association related problems are solved in the unsupervised machine learning. There is a data like where customer segmentation or you would like to do the market basket analysis, association. So that comes under the unsupervised machine learning. I'd like to see some more questions here. Okay, so yeah, I think you're okay. So you can just write the questions in the comment box. Whenever there's a break, I will try to answer it then. Fine. Now there are different types of problem to be solved, and for different types of problem, we have different types of machine learning algorithm also. So let's say you like to have a solve the problem like a driverless car. So like automobile sector. Nowadays we are talking to we are discussing more about Tesla car. Now Tesla car, why we are discussing about Tesla car? The reason is the Tesla has invented, or even the Google driverless car. Why we are discussing? Because that car is something which is taking the decision, and that car is like without a driver, means the machine is taking the decision to drive on the congested part also, congested path. So how the car can be driven without human, that like already like Tesla has proven. So that is all because there is a reinforcement learning is there, and under the reinforcement learning you will see there are two categories again like classification and control. So one of the example of reinforcement learning is a driverless car here. Again, it's a very huge topic, so I don't want to explain each and every example here, but just to give the idea that with the help of example that what machine learning is and various algorithms which are there. So there are three categories. You always remember: supervised, and somewhere it is said semi-supervised also, supervised, unsupervised, and the reinforcement learning. In all cases, we have a input data. In all cases, what you will see, there is a training data. We'll understand what is training data means. Then later we'll also understand like how do you actually train the machine or train the model, and then how machine do the prediction, how exactly the things work. That also we are going to see practically also. So this particular image is telling you like how the machine learning works here. So I told you like supervised machine learning means where there is a label data, where we provide the data which is a label data, and we train the model, and based on that there is a prediction of the output. So here what happened in this case, the system creates a model we call the with the help of the label data, and then machine understand that that the algorithm understand the data set for that is learned from the input data, and with the help of with the help of this model. So this is like a training, right? We are giving a training based on the training data. The input data is called the training data. So don't think like, okay, what is training data? So training data is nothing but the input data, which is a label data in this case, in the case of supervised machine learning. And then we do test the model by providing some sample. So we have one more thing called test data. So I'll explain you what is test data also. How we test the model also, that also I'll tell you. So based on that, we check whether it is predicting the exact output or not then. Because we also need to check some, it is not necessary that every time machine is predicting correctly. So accuracy may change. So we have to check whether the machine is giving you the accurate prediction or not. So we have to test for that. As I told you, like in unsupervised machine learning, we don't have predetermined results. We have a categorical data. We have more cluster rated problem here. So here machine try to find out the useful insight from the amount of data. So this is, in this case, you have to have clustering. So you do not have the clear picture. You don't have label data in this case. So this is all theory part, which I just wanted to give as an input for you to understand the case study here. And I'll be taking the example of supervised machine learning only. Okay, some more input, like for the reinforcement learning, when to go for reinforcement learning. It is all feedback based learning method here, where learning agent gets a reward for each right action and get penalty for each wrong action. So in this case, the agent learns automatically with the help of feedback. If you got the reward, it means it's the right direction. So it's like a robot. You are telling the robot that what is correct, or what is the right action and what is the wrong action. And based on that, machine is performance get improved here. So I'm giving you example. For example, in this case of the robotic dog. How the robotic dogs works, it is based on the reinforcement learning only. So in this case, agent interact with the environment and explore in this case, what happened, you are giving the reward point to the machine. Here, let's say it's a robotic dog, that if the right action is there, then you are giving the reward. So this is what we did, like, or we give the penalty here. Now, and this was to give you the idea, the different types of machine learning algorithms, and like I have just given you a brief idea here. Now understand the complete flow here. That is the machine learning life cycle. Now, machine learning life cycle is nothing but the cyclic process to build an efficient machine learning project. Now, it allows you to find a solution to the problem or a project here. How does it work? You are going to see with the help of example here. So it create a machine learning system. That machine learning system is called model. So most of you guys may have question, what exactly the model is all like the machine learning system or the algorithm which we have now. So model is created by providing the training data set. And here, how does it work? We train the model and by using the input data here. Okay, fine. So understand the complete life cycle now. The first thing is, if you really want to work on the machine learning, first thing is you need to gather data. Now, you may gather data from various sources, but how do you gather data? It is based on the types of problem. Whatever problem you have, like whether it is a housing problems or whether it is a stock problem, so whatever you want to predict, based on that you will, or what are the hypotheses you have, what are the problems you like to solve, based on that you need to gather data. I'll be showing the example, like how do you do that process, and I'll be showing the with a practical example here now. Then we have a data preparation process, then we have a data wrangling, then analyze the data, then train the model, test the model, and then finally deployment. So these are the 7 steps of machine learning life cycle. We'll be applying this 7 step within the example itself, and for that I will recommend you to first understand this 7 step, and then with the help of a Jupyter notebook we will try to apply it. So gather data as the what exactly the gather data, it like is identifying then all the problem. Based on that you need to gather data. Data could be in the form of files, or could be you may take data from the internet source or mobile device. So here it is all about the quantity and the quality of data. Better the quantity and the quality of data, better the chances of, or you can say accuracy in that case, the better the prediction in that case, right? So based on the problem, start identifying the various data sources, then collect the data. That is what the gathering of data now. Then next thing comes data exploration or data preparation now. So let's say you collected the data. It is not necessarily that the data whatever you collected is accurate data, or it is not necessary, it is related to your problem also. So first, even after gathering data from various sources, maybe in the form of Excel, maybe in the form of CSV, maybe in the form of some text. So that data, once you gather it, you need to explore it to know about data. How do you know about data then? So you will require to visualize the data for that. So data exploration will help you to visualize the data, understand which are the rows are there, what type of data it is there, all that columns, or we can see the features of the data. So this is all we do in the data preparation. We understand the nature of the data, we understand the characteristics of data, we understand the formats, quality of the data, we find the correlation between the data, what is the general trends, is there any outlier is there. All these things we do in the data preparation. And also we try to see like what data it is, whether it is a categorical data or it is a numerical data. Again, there is a lot of thing in the category: nominal data, ordinal data, or interval data, ratio data. So again, there are example of data itself. Nominal data means what exactly, what is ordinal means, what is interval means. So there are some example. You can see a new car model comes in this color, like we have a categorical data like color, having the black, blue, white, whether it is a black color or blue color. So that comes as a categorical data. Where when it is ordinary means where is it extra small, or medium, large, those kind of things, right? And when it is a interval data means it's like a calendar data, or you can say temperature. So that is called interval data. So what about this ratio data? It is all about temperature in the Kelvin, or you have age, length, electrical current. So that comes in the ratio data. So we have a different types of the data itself. The next step is data wrangling. Now, once we have understood the type of data, we understood, let's say, we have some idea about data. What we do is we do the cleaning of the data. Why cleaning of data? Because the data, you may have some record which are null records. You may not have all the columns in each data set. So you have to check the data set, whether that data set is having any empty record or anything is missing in that case. So all that we have to check it. So here data wrangling comes into picture. So processing of cleaning data happens in the data wrangling. So we select the variable use, transform the data also in the proper format. So sometimes it happens you have a data which is in the format which is like a categorical format, and you need to convert into the binary format or maybe the numerical format. So that transformation also we do in the case of data wrangling only. So you collect data which may include the missing value, which may have a duplicate data, which may have invalid data, we may have a noise. So all that thing we need to sort it out in the data wrangling. This all do in data science only. This doesn't come, see, in machine learning, the first thing comes data science, where we do this data cleaning, data wrangling and all. Then once you are done data cleaning and all, the next thing is you are doing the data analysis. Then in the data analytics, you are taking the data, and here we are giving the machine learning algorithm to build the model. So here you are building the model. Then you decide what analytical technique should be used here now, and then review the result. So there's a lot of things we do here. We decide the types of problem. We select the machine learning technique which is suitable for your problem, whether we should go for the classification related or regression or cluster analysis. All this we are doing in this case of data analysis now. So you build the model using the prepared data here, and evaluate the model also in the case of fourth step. Once that's done, then you are training the models, train the models. This is to improve the performance, and so training the model is done, is the fifth step, you can say. So this is like you are having the clean data now. You already filter out all the data, like whichever the missing value, you have everything you are taken out. So so here the fifth step is a training. So we have a training now, the more clean data now, and now this algorithm try to understand the various patterns and the rules based on the input data now. Once that is done, once the training is done, you test the model and check the accuracy of the model here, and provide the test data set. So these are all steps which we do in the case of machine learning. And here we come to know the accuracy of the model also, whether it is matching to a project requirement or not. And the final stage is the deployment here. If you find the model is producing accurate result as per the requirement with acceptable speed, then you can deploy the model in the real system. That is what the last step is. Now let us, because I just wanted to do some theory part and the life cycle here. I hope you understood like the basic here, that how exactly it works, like uh, the life cycle and what machine learning is, and different types of machine learning. Now, how to start? For that, you need to have the Anaconda. You can watch my previous video also where I have told like how to install Anaconda in the Python. In the Windows machine, you may, once you have installed the Anaconda, you can look for the Anaconda Navigator, and then this Anaconda Navigator screen can be started. I'll be showing you practically all this thing, and then we'll start the simple linear regression. So let me tell you, like now, the hands-on part will start now. I'm starting the Anaconda here. And there I'm going to show you the simple linear regression. This is for all demo part. Okay, and let me tell you how I started. So one by one step I would like to show you here. First, I have to start here. Once the Anaconda Navigator start, here I'm starting the Jupyter notebook, and I need to first launch the Jupyter notebook. Once the Jupyter notebook is launched, you will see on the browser there will be a notebook. Here I have done some various home page. You will see there. Let me start this. I'll show the data set also so that you understand how does it work. So home page, let me share the screen once again. So here it comes then. And from here you have to say new and Python 3, right? Then once this is done, I already created one notebook here now. Here I have said a simple linear regression. I have just created one notebook. I'll just show you one more notebook here. We'll be using the machine learning model or algorithm, you can say sklearn. So first you just test it in the notebook itself, the print, whether it is notebook is working now. Welcome to machine learning. Just test. So you can just check like whether this Anaconda is working or not. So you can and check the various library. For example, import NumPy as NP, import pandas as PD, import. Again, let me tell you, here there is a prerequisite that you should know data science. So I have actually taken the one workshop for data science only, that is on NumPy as well as on the pandas, matplotlib, and various other things. And then you have sklearn. You can just check all this library here. Sorry. First, let me do this. Okay. Now, I'm just showing you like these are the library we'll be using here now. Right? Pandas as a PD, NumPy as PD. So why this panda? Let me explain each and everything here. Pandas, with the help of pandas, we'll able to clean the data, we'll able to read the data, we'll able to create data frames. So what are the data cities? So I'm starting the case study here for the simple linear regression where I'll be taking the sales data now. So understand we have a data, very simple data where we have a years of experience as a one column. So let me tell you like how the data set is. So this DF, okay, let me show the sales data where it is. It is it's a CSV file now. So we'll get the idea like how the data set it is. Or I can show you the data frame itself. I'm just opening the data set so that you will come to know how it is. In machine learning, I'm just opening the data so that you understand how data is first. Okay, so just new sharing the data set. Okay, I have a data set called sales data here, where this is just like a years of experience and this is salary. This is a salary data, sorry. One more data set, I have to check it. I have opened multiple data set. Okay, so let me tell you like what data I'm taken here so that you can see that first. And I have kept that as a salary, sorry, this is salary data. And here there is a salary data. Okay, let me tell you that input data is a salary data only. So it was a correct one only. So it has a years of experience. Based on that, there is a salary now. New sharing, this one is the data. There is salary data. So you have, let's say, years of experience, and based on there is a salary. Okay, only two variable data we're taking. One is years of experience and one is salary here. This is the data. Let us take, so this is what, where we understand the linear regression now. And this data I have taken as an input data, salary data here. I'm using the model, it's a linear regression model. Okay, this is a linear regression model here. And there are various models I'm using here. NumPy, Matplotlib is for the plotting the data. Pandas is for data science, like for cleaning the data, for reading the data. NumPy is for performing the various numerical operation or matrices operation, array operation. Then other algorithms, like we have a we like to have model selection, like for the training and testing this data. So these are all like library you will be using here. Here will be using the simple linear regression to solve the problem. Now, let me give the idea about this simple linear regression now, what exactly it is, so that you'll understand what I'm doing now. New share. So what is simple linear regression? It is a model where there is a relationship between a dependent variable. So there is a one dependent variable and there is a single independent variable now. And what you see, there is a relationship in the form of slope or linear line now, or straight line. So simple linear regression include the dependent variable and the independent variable, which include, in this case, we are taking the continuous variable in our example. So you'll have either continuous variable or you have a real value. So you will understand what dependent variable is, what independent variable. So I told you in the previous case also, independent variable is something x-axis we say, right? Where it is like a year. Year could be the independent variable in the case of salary data. If you take the salary data, the years of experience is something which is independent. But what is dependent? Dependent is salary. So generally what we say, the more the experience, more the salary, right? So if you would like to, let's say, find out how the employee salary is changing based on the experience, and you would like to calculate for some organization. So you may have a data for the each and every employee, which include the years of experience as one of the parameter, and the second is the another parameter is just like a salary itself. Although in the employee data set, you may have so many other features also. You may have performance factor, you may have lieu factor, you may have some other factor, but we are just taking the major factor as in this case as a experience now. Although I not add the skill as a input factor in this case, I'm just taking the input factor as a experience and the salary now. So in the simple linear regression, what happened in this case, we are having the model which shows the relationship between these two variable, dependent and independent variable. So what are the example? It could be an income and expenditure, or experience and the salary, or forecasting the new observation. So all this comes into the simple linear regression now. What is the formula for that? For simple linear regression, you have the formula called y equal to, you have a0 plus a1x plus e. I'll be explaining what is exactly this. So let me see what. So like there is a one previous formula called y equal to mx. You must have here, like there's a linear line is there. That's all mathematical things where y is what? Y is your dependent variable, because y value may change based on the independent variable, that is x now. What is a0? A0 is the intercept of the regression line. Like here is x. I'll tell you, like, there is a a0 and there is a a1, or somewhere case it is like a beta 1 beta 0. So there is a y-intercept and there is a x-intercept now. So a1 is the slope of the regression line. Whatever the slope you see, like m is there, m is also called slope, right? That is a regression line, and e is the error now. So we'll see, like okay, that's all theory part. Let me show you the. Okay, I'll give some brief idea here. How does it work? Because with the help of this mathematical model only, we are going to calculate something. For example, I'm saying like we are having the data which is our salary data, where we have input data which is experience, and we have a experience as well as the we have salary now. So now which is a dependent variable in this case and which is independent? Experience is a independent variable, that is a x, right? And which is a dependent? Y. So y is your salary. Salary is a dependent. Okay, so I think yeah, this is what we generally do. First step is data pre-processing. For that we use a library like we'll be using the importing the things like pre-processing means you are importing the various library like NumPy, Matplot, Pandas, where now here you may read the data in this case, whichever the data set is there. Right now we have a salary data set, so we'll be reading that. Then based on the salary, you have, let's say you have one thing is a years of experience, and then based on that you have salary now. So here, yeah, we have to just do the column wise data. So I'll be showing you like how you are going to do it with the help of example. So I think this is just like a, okay, let me stop this part and show you the Jupyter notebook now. So let me tell you, linear regression is a very, very simple model to solve the basic problem. This is all based on the linear formula called m, which is the slope, and the b, which is the line. You can say b is where the line starts. So that is called the your y-intercept also. Now you may have a relation like you may have a the value could be negative, or like here you will see the slope could be negative or positive, like that also you will see here. So in this case it will be positive relation. Okay, so how do you read the data? The first step is once you import the or load data, like once you gather data, once you already have data, you will be loading it in the form data frame. So here I'll show the data frame. If I have a data, this is the data frame now. Now this data frame, you have a years of experience as a one column and the salary as a another column now. Here I'm showing you something like, let's say you want to, okay, let me add the cell below. Let me describe the database now before we go ahead. What this data frame is describing to us. it is telling you the number of, uh, you can say the count is there, that there are 30 records are there. You can see here there are 30 records starting from 0 to 29. That's why there are 30 records. And what you see is the mean value, standard deviation, minimum value, and the percentage and the max value also. So you can see the experience, which is the max experience is a 10.5 here, minimum experience is the 1.1, minimum salary is you can see here like 37,731, and maximum is 1,22,000. So this is what you can get the idea when you describe the data. You can also find out. So yeah, I'm just trying to understand data now first. You can also find out info. Info will tell you about the types of data. Now what you see, these columns, this column is having the like years of experience and the salary, and both the columns are of float type now. So here, if you do not know about the data, you don't have idea about data, first you find out about data itself. So we are trying to explore data now, right? And finding out what data it is. So it has two columns. You can see it includes the years of experience and the salary. You can this we can see by df by head also, right? Like what is df dot head? This just gives you the first 5 columns, first 5 rows, right? And what the df dot tail will be, it is the last 5 rows in that case. What is the df dot shape? Df dot shape is telling you like how many rows are there and how many columns are there. So in this our data set, we have 30 rows and 2 columns. That is what the df dot shape means. Now we like to find out whether this data set is having any null value or not. You can find out by is null or dot value. So this way you can find out whether is any data set is null or not. If it is false, means it's not there, right? So we have a clean data right now. Once we have done that process, once we have cleaning the data, we have everything done, the next step is to split the data. That is like, where, because we are going to do what? Splitting the dependent variable and independent variable now. Now here in this case, we are just having the 2 variable, that is a salary and the years of experience, and that's the data frame. So how do you split now? We can split by various way. You can use the split method also, and you can access the data whichever like a column, whichever the column you want to access. There are various ways to access the column also. So here one thing is like you can split the dependent variable salary and the independent variable, which is the years of experience, right? So we can use a train underscore test underscore split. This is something to split the data into 2 models, that is training data set and the test data set. Here this is. So that comes in the machine learning model. You have sklearn.model selection, where you have a train underscore test underscore split. In case you want to divide the data into 2 parts, that is a training data set and testing data set. So again, these are the concept to understand, like what is training data set and what is testing data set. Testing data set is the same portion, like is a whatever the data input data set is there. From there, let's say you may have a percentage, like you may have a 20 to 40%. So from input data set, you just take some portion of it, and that is in percentage. Either it could be a 20 or 30, or you may take the 40%. So that is for testing the model itself. So if you want to do that, we can do this by using the train underscore test underscore split. Then here test size is 0.2 means 20%. Then we are creating the one more data frame here. That is after creating the the training data set, 1 copy we are creating. So that is what df underscore copy is another data frame now. You can see it has a now 42 rows and the 2 columns here. And what it includes is again so it means like we have taken, why 24 rows only now out of 30? Why 24 rows? Because we have taken the training data set, which is a 80%. 80% is our training data set. That's why we got 24 here now, 24 rows here, and remaining 6 rows will be given to the testing data set then. That is what you can see in this example. Then we are doing something like describing our this what is the copy we created. That is this is our training data set. Here we are describing this training data set itself, as we were doing for the entire data set. This is for training data set only. Then we can find out the correlation between this data set. So these are method available correlation. We can find out how testing data set is related to the how this years of experience is related to salary. So let me tell you, like this correlation is like to telling you, like, positive correlation or negative correlation. Now here you can see the value of correlation in this case is very near to the 1, right? It means it has a it is highly correlated, right? When it is like a so correlated value comes either -1 or 1, positive correlation or negative correlation, that comes to the correlation here. So or you may have, if there's no relation, the value will come as a 0 then in that case. So yeah, this is the way you need to work out on the testing data set, and then you can plot the using the various plotting algorithm. Like we have a plot related to we have taken the model called there's a matplotlib. Using this also you can plot the plotting is for visualization of data, or Seaborn. These are the various Seaborn is also there. Seaborn is again for visualization of data. Using this also you can plot it. And once this is done, you can see how there is a relationship between the years of experience, and you can see that the observation. This is data set now. This is the plotting of the data now. So it includes the years of experience, which is your independent variable, right? And this is the salary, which is a dependent variable. And this is something, the input which you can plot by using your Seaborn, and this is a regression line now. What you see is a linear regression line now. This is clearly telling you like positive linear regression because as the experience is increasing, you can see the salary is also increasing now, and they are very much related to this linear regression line now. So based on this, we can have the prediction. So we are making the 3 data set, like in this case model, like we have a test set, we have a training label set, and based on that we can have now in this case you may change the experience, and based on the experience you will be able to calculate the salary also. Again, this is a little bit a big case study. I think most of you guys are trying to understand the entire case study. It is going to take a lot of time. So here I'm just giving the idea like how you can use a machine learning to solve the basic related problem, maybe the just experience and the salary. Based on the experience data set and based on this data set, you can have linear regression, and you can try to calculate some other thing also. Okay, so here I think it is going to take time, so I'm not going to deep up this topic right now, because I have one more session in the maybe on Sunday, where I'll be telling you like how you can do in a very simple example, step by step. There in the notebook I'll be typing each and every lines, and will explain you how even logistic regression work. And we'll have the next workshop where I'll explain you the difference between the linear regression and the logistic regression. Okay, this is all about the basic about the machine learning here, and let me conclude here with some input, like what we are learning in the today's session is the basic about what is machine learning, the different types of machine learning, the various applications of machine learning, the algorithms which are there in the machine learning, and I try to cover some just demo. I would like to say like there's a model like linear regression, which is one of the machine learning algorithm, and we try to take the simple linear regression as an input here. And based on that, we were just trying to calculate the salary. Let's say you have certain experience. Based on the experience, how do you calculate the salary of the person now? So for that, we have given the input data as a years of experience and the salary. So here this was a supervised machine learning. So we understood like what is supervised machine learning. unsupervised, and the reinforcement learning. So this type of problem we call supervised, where because the label data is there. What is label data? We know now the input data, like that there's a years of experience. We know the data here as a salary here. So this is a known data. And based on this, we are giving a training to the model. And here we use a linear regression model. Linear regression model is a very, very simple and the basic model. In this, we just give the input data, and based on that, now let's say you want to calculate if I have the experience of, let's say, 10 years, what will be my salary? If I have experience of 20 years, what will be my salary? How it is calculated? It is based on what are the input data is given to the machine. Based on it will just give the predict. You may not get the exact salary amount, but then you get a predictable output. So it is just like, certain prediction, you can say. So let's say somebody is having that 15-year experience. You will give the model, once we are trained the model, you will just say, okay, if this is a 15 years experience, what will be the salary then? And that way the machine will tell, okay, if this is a 15-year experience, the salary is 2 lakh rupees, like that. So this is the way the machine learning work here. I hope you understood like what machine learning and the basic about machine learning, although it required many more session to understand the machine learning, to understand the various concepts. In this particular session, I just wanted to give the brief about the machine learning. In the next workshop, I will try to cover the concept of the machine learning with what is the concept, like what exactly outlier means, what is correlation means, and also we'll try to cover the logistic regression concept also. There I'll be directly focusing on the use case